Okay, so what we're doing here is looking at inequations. Now, they are, wouldn't say they're the opposite of equations, but they are things that are not equal. And we represent not equal with either less than or greater than, and sometimes less than or greater than, less than or equal to, or greater than or equal to. So, what we're going to do, we're going to look at how to solve them. We're going to look at representing them on a number line, and then we're going to look at a couple of little changes here and there. So basically, the first thing we're going to do, we're going to have a look at drawing them on a number line. So just if we've got x greater than 5 or x less than equal to negative 2, that's what we're saying here. So what we're doing here, we're going to draw these on a number line. So we're saying x is greater than 5, so I'm going to draw 4, 5, 6, 7, 8. And over here we're going to say x is less than or equal to negative 2. So I'm going to go negative 2, negative 3, negative 4, negative 5. Okay, so what we're saying here, we're saying that according to this, x is greater than 5, it can take on any number so long as it is more than 5. So any number that's more than 5, well, we know 6, 8, 8.2, 9.71 are all bigger than 5. So what we do is we start our arrow, we start a line at 5, and we draw it, and we put an arrow in there saying we're going to 5. Now, because we've got a greater than, we've got to change the symbols. We have to represent the other end. Now, if it's an equal to, less than or greater than, we have a closed circle. If it is just less than or greater than, then we have an open circle. So over here, we are going to have an open circle. Over here, what we're saying is less than or equal to 2. We're going to have a closed circle. We are going to have an arrow extending to all the numbers less than negative 2. So that's how we show these on a number line. Now, we've got, for our inequations, here we have 3x plus 1 is greater than or equal to 1. We solve these exactly the same way as equations. We're saying 3 times some number plus 1 is greater than 1. We're looking for what that number has to be, or it could be equal to 1. So we take our 1 over to the other side, we're subtracting 1 from both sides. So we've got 3x is less than or equal to 0. And from there, 3 times some number is less than or equal, is greater than or equal to 0. That number has got to be less than or equal to 0. Because as soon as it's greater than 0, for example, if it is 1, or if it is 2, or if it is a third, whatever the case may be, so long as we have any number, it's going to be greater than 1. or equal to 1. So x has to be greater than or equal to 0. Very similar here for the next one. We're saying negative 2 times some number minus 5 gets us 15. So what we're going to do, we have to add 5 to both sides. So we've got negative 2x plus 5 to cancel that becomes greater than 20. Now, because we're going to divide by a negative number, we're going to divide both sides by negative 2. This becomes x. We flip our sign. Negative 10. So what we're saying here is we're saying x has got to be bigger than negative 10. So any number bigger than negative 10 will make this inequation true. For example, if we make this negative 9, 2 times negative 9 gives us 18 minus 5, which will be less than 15. Because we end up with 13, and 13 is less than 15. So that's the trick. That's the thing you've got to remember. If we're dividing or multiplying by a negative number, you flip the sign. Okay. Now for the last one we're doing, a little bit different number line. We're saying we've got some number, 3, is less than some number, which is also less than or equal to 5. So what we're saying is that we can go anywhere between 3 to 5. X can be any number between 3 and 5. So to draw that, what we do, because we've got the, it's just a less than here, we do an open circle at 3. Because it's a greater than or less than, we put a closed circle, and then we join them up together. For our last one, we've got to rewrite this a little bit. So what we're going to do here, we've got x take away 7. We're going to add 7 to everything there. So this becomes 4 plus 7 less than or equal to x, negative 7 plus 7 less than 2 plus 7. So this is becoming 11 less than or equal to x less than 9. So I haven't done this. I should have had these. I should have had these two numbers the other way around. Didn't realise that I'd have this being incorrect. So really, mathematically, we should have our 11 over this side and our 9 over this side. Anyhow, we're still going to have our number line. 9, 10, 11. 11, and we're going to say that we have greater than, an equal to there, an open, and we join them up. So, in equations, this is how we represent them on another line. If it's just less than or greater than, it's an open circle. If there's an equal to, it's a closed circle. Greater than a number, we draw an arrow in a positive direction. If it's less than, we draw an arrow in a negative direction. Just saying that x can take on any number more than 5, x can take on any number less than -2. If we're solving, we solve the exact same way as we do an equation. But if we divide or multiply by a negative number, we flip the sign. And from there, we can always check it. If we're given something like this that tells us we're going to draw between 2 points, the two values we've got on either side. So in this case, we're going to go between 3 and 5. Less than or equal to, close bracket, less than, a open bracket, or an open dot. If we've got a little expression here in the middle, we've got to make that expression just have x. So in this case, we've added 7 to both sides, and from there, we're just left with x in the middle, and then we redraw another line again.